Hello everyone, welcome back to our Python programming full course. In the previous lecture, we learned everything about Python strings, including indexing, slicing, operators, and important string methods. Today, we are going to learn another very important topic called lists. Lists are one of the most frequently used data structures in Python. Almost every real world Python application uses lists in some form. Whether you are storing student marks, employee names, shopping items, product details, or even machine learning data sets, lists are used everywhere. So, understanding lists is very important if you want to become a good Python programmer. In this lecture, we will start from the basics and gradually move towards practical examples. Let us begin. First of all, I tell you what is a list. A list is a collection of multiple values stored inside a single variable. Instead of creating many variables to store similar data, we can store everything inside one list. A list can contain numbers, strings, decimal values, Boolean values, or even another list. One interesting feature of Python lists is that they can store different data types together. Lists are written using square brackets. Let us do some programs. First of all, I will tell how to create a list. Numbers equal to brackets open 10, 20, 30, 40, 50. Next, print numbers. Let us run this code. It will print 10, 20, 30, 40, 50. Here we created a list called numbers. It contains 5 integer values. The values are separated by commas and enclosed inside square brackets. When we print the list, Python displays all the elements. Let me clear this one. Now I will show how to create list with different data types. Data equal to brackets open 10, and I will write Python 25.5 true. Print data. Now let this run. It printed this. Unlike some programming languages, Python allows us to store different types of data inside the same list. Here we have an integer, a string, a floating point number, and a boolean value. This flexibility makes Python lists very powerful. Why do we need lists? Imagine you want to store the marks of five students. Without lists, you would create five different variables. As the number of students increases, managing those variables becomes difficult. A list solves this problem by storing all related values inside one variable. This makes programs shorter, cleaner, and easier to maintain. Let us create a program without list. M1 equal to 85, M2 equal to 90, M3 equal to 78, M4 equal to 88, M5 equal to 95. Print M1 comma M2 comma M3 comma M4 comma M5. Addition, it means 85, 90, 78, 88, 95. Let's do another one with marks equal to 85 comma 90 comma 78 comma 88 comma 95. Print marks. Run this, it shows same. Compare both programs carefully. The second program is much shorter and easier to understand. This is why lists are preferred when working with multiple values. Now I will explain what is list text. Just like strings, every element in a list has an index. Python starts indexing from 0. The first element has index 0, the second has index 1, and so on. We can use these indexes to access individual elements. Let us do one program. Fruits equal to apple, banana, orange, mango. Print zero. Now this it prints apple. Index 0 represents the first element. Therefore, Python prints apple. Now create another one. Fruits equal to apple, banana, orange, mango, green, fruits, what? Green, fruits, two, green, fruits, three. Now run this. It prints banana, orange, mango. Here we access different positions in the list like 1, 2, 3. Each index returns the element stored at that location. Now let's talk what is negative index. Lists also support negative indexing. The last element has an index of -1. The second last element has an index of -2. This is very useful when we want to access elements from the end. Let us do another program like fruits equal to apple, banana, orange, mango. Print fruits of -1, print fruits -2. Just run it. Here, -1 returns the last element, which is man. -2 returns the second last element, which is orange. Negative indexing saves time because we don't need to know the total number of elements. So let us do another program. Names. What is that? For I in dreams. Name equal to input, enter a name. Names dot append print names. Session it, enter a name. I'm entering my name. It's showing enter a name. I'm entering again. In this program, we first create an empty list. Then we ask the user to enter three names. Every name is one second, I will enter the name. Another. Every new name is added to the list using the append method. Finally, we print the complete list. Excellent. Today we learned what a list is and why it is one of the most important data structures in Python. We learned how to create lists, store different data types, access elements using positive and negative indexing, and even take user input into a list. In the next section, we will learn list slicing, traversing lists, and many practical examples. Back everyone. In the previous section, we learned what lists are, why we use them, how to create lists, and how indexing works. We also learned positive indexing and negative indexing. Now we are going to learn another important concept called list slicing. Sometimes we don't need the entire list. We may only need the first three elements. The last two elements are elements between specific positions. Python provides list slicing to make this task very simple. After that, we will also learn how to access every element of a list one by one using loops. Let us begin. First of all, what is list slicing? List slicing means extracting only a required portion of a list. Instead of displaying every element, we select only the elements we need. The syntax is, I will show you. This is the syntax. Here, start indicates where slicing begins. Stop indicates where slicing ends, but remember that the stop position is not included. Step tells Python how many positions to move after selecting each element. At first, this may look confusing, but after a few examples, it becomes very easy. Okay, let us let's go for programming. Numbers equal to 10, 20, 30, 40, 50, 60. Print numbers is to 4. Yes, and this observe the output 20, 30, 40. Let us observe indexes carefully. Index 1 contains 20. Index 2 contains 30. Index 3 contains 40. Since the stop index is not included, index 4 is ignored. Therefore, the output becomes 20, 30, and 40. Let with another program, numbers equal to 10, 20, 30, 40, 50. Print numbers G. Now run this. It's showing 10, 20, 30. When the starting index is omitted, Python automatically starts from index 0. Therefore, the first three elements are printed. Now see another program. Numbers equal to 10, 20, 30, 40, 50. Print numbers. Just run it. Mission 30, 40, 50. Here we specify only the starting index. Python starts from index 2 and continues until the last element. Let's see another one. Again, numbers equal to 10, 20, 30, 40, 50, 60. Print numbers. Just run it. Showing 10, 30, 50. Here the step value is 2. Python selects one element and skips the next one. Therefore, only alternate elements are displayed. Now let's see how to reverse a list. Numbers equal to 10, 20, 30, 40, 50. Print numbers minus 1. Observe the output. The step value is minus 1. A negative step means Python moves from the last element towards the first element. This is the easiest way to reverse a list. Let's see what is traversing a list. Traversing means accessing every element of a list one after another. This is one of the most common operations in programming. Python allows us to traverse a list using both for loops and while loops. Let us understand both methods. Let's do a program for traversing using for loop. Fruits equal to apple, banana, orange, and uh, fruits. Fruit in fruits. In fruit. Return this. Give apple, banana, orange, mango. The for loop automatically picks one element from the list during each iteration. The current element is stored in the variable fruit. Then Python prints it. This is the simplest and most commonly used method. Let me clear this. Let's see. Traversing using while loop. Our loop is over. Next while loop. Fruits equal to apple, banana, orange, mango. I equal to 0 while I let the fruits. Then fruits. I equal to I plus 1. Now just run it. Output was apple, banana, orange, mango. Here we use an index variable called I. The length function tells us how many elements are present in the list. The loop continues until all elements are printed. Compared to the for loop, the while loop gives us more control over the index. Let's do print index and value. Let's print index and value. Fruit equal to apple, banana, orange, mango. For I in range, the fruits. That's here also fruits. Right. Fish will come to farmer. Roots. I have this objective output. Sometimes we need both the index and the value. In this program, the range function generates index values. Using those indexes, we access each element one by one. This method is useful while updating or comparing list elements. There's sum of list elements. Numbers equal to 10, 20, 30, 40, 50. Total equal to 0. For num in numbers. Total equal to total plus print sum, comma, total. Run this code. Sum equal to 150. This is a simple real world example. We first create a variable called total and initialize it with 0. Then we traverse the list. During every iteration, the current element is added to the total. Finally, Python prints the sum of all elements. Let us discuss about common mistakes. First, remember that the stop index is in slicing is never included. Second, beginners often confuse list indexes with element values. Finally, while using a while loop, always increase the index variable. Otherwise, the loop may never stop and create an infinite loop. Excellent. In this section, we learned list slicing and list traverse. We understood how the start, stop, and step values work. We also learned how to reverse a list and traverse it using both for and while loops. Finally, we solved a practical program to calculate the sum of list elements. In the next section, we will learn list operators, built-in function, and more practical examples. In the previous section, we learned how to slice lists and how to traverse them using both for and while loops. Now we are going to learn some very useful operations that programmers use almost every day while working with us with lists. We will learn list operators and important built-in functions. These concepts will help us combine lists, repeat lists, check whether an element exists, and perform useful calculations like finding the length, sum, minimum value, maximum value, and sorting. Let us begin. First, let us talk. What is list concatenation? Concatenation means joining two or more lists into one larger list. In Python, we use the plus operator for concatenation. It does not modify the original lists. Instead, it creates a new combined list. Let's do some programs. Concatenating two lists. List 1 equal to 10 comma 20 comma 30. List 2 equal to 40 comma 50 comma 60. Result equal to list 1 plus list 2. Print result. Prints 20, 30, 40, 50, 60. Here the plus operator joins both lists together. The first line remains list, the first list remains unchanged, the second list remains unchanged. And Python creates a new list containing all elements. Now see concatenation string lists. Concatenating string lists. Roots apple banana. Orange mango. Print roots 1 plus roots 2. And run this. It brings apple, banana, orange, mango. Concatenation works not only with numbers but also with strings and any other data types stored inside lists. Let's talk what is list repetition. Sometimes we need to repeat the same list multiple times. Python provides the multiplication operator for this purpose. Now, let's do repeating a list. Numbers equal to 1, 2, 3. Print numbers in numbers in 3. Now just run this. Repeats 1, 2, 3, 1, 2, 3, 1, 2, 3, 3 times. Here, the list is repeated 3 times. This does not multiply the values. It simply copies the entire list repeatedly. Now, let's talk what is membership operators. Membership operators helps us check whether a particular element is present inside a list. Python provides two membership operators in and not in. In not in. Now let's create a program with using in. With banana orange. With apple in fruits. With mango in fruits. Let's run this. It brings true, false. If the element exists, Python returns true. Otherwise, it returns false. Just to end the program with using not if. Fruits equal to again apple, banana, orange. Okay. Mango, not in fruits. Okay. Apple, not in fruits. Just of this, it brings true, false. The not operator gives the opposite result. If the element is option, Python returns true. Now let's talk what is list comparison. Python also allows us to compare two lists. If both lists contain exactly the same element in the same order, Python returns true. A equal to 10, 20, 30. B equal to 10, 20, 30. Print A double equal to B. Now run this. It brings 2. Create another program. A equal to and 20, 30. B equal to 30, 20, 10. And A double equal to B. Now run this. Press false. Even though both lists contain the same number, the order is different. Therefore, Python returns false. When comparing lists, both values and their order must match. Now let us discuss what is built-in functions. Python provides several built-in functions that make list operations much easier. Let us learn the most commonly used ones. Numbers equal to 10, 20, 30, 40, 50. Print and the numbers. Just run this. It prints 5. The length function returns the total number of elements present inside the list. Now, numbers equal to 45, 12, 89, 27. Print minimum of numbers. Print minimum of numbers. Yes, run this. Maximum number was 89, minimum number was 7. The minimum function returns the smallest value. The maximum function returns the largest value. Now let's go to another program. Numbers equal to 10, 20, 30, 40. In sum of numbers. Now run this. It shows 100. The sum function adds all the numbers present inside the list and returns the total. That's equal to 45, 12, 89, 27. Then sorted out numbers. Just do this. Prevent 7, 12, 20, 45, 89. The sorted function arranges elements in ascending order. It creates a new sorted list and does not change the original list. Numbers equal to 45, 12, 89, 27. Print, rotate, numbers, comma, reverse, equal to 2. This like this. Print 89, 45, 20, 12, 7. By using reverse equal to 2, Python sorts the list in descending order. Now let's see one last practical example. Marks equal to 85, comma 90, comma 78, comma 88, comma print total students length of writing highest marks, maximum of marks, print lowest marks, minimum of marks, print protect marks, started of marks. So just on this, the top students was highest marks was 95, lowest marks was 78, total marks was 436, total marks were this one. This is a practical example that combines everything we have learned. In a real student management system, these functions are used to analyze mocks quickly without writing lengthy code. Let us discuss some common mistakes. First, remember that the plus operator joins lists. It does not add corresponding elements. Second, the multiplication operator, like this star operator, repeats the list. It does not multiply each element. Finally, functions like sum, minimum, and max work properly only when the list contains compatible numeric values. Excellent. In this section, we learned list concatenation, reputation, membership operators, comparison, and important built-in functions like length, minimum, maximum, sum, and shorted. These functions save a lot of time and are used in almost every Python project. In the final part of this lecture, we will learn the most important topic, list methods. We will explore methods like append, extend, insert, remove, pop, sort, reverse, copy, and many more with practical examples. Thank you. Welcome back, everyone. So far, we have learned what lists are, how to create them, access elements, slice them, traverse them, and perform various operations. Now, we are going to learn the most important part of this lecture, list methods. List methods are built-in functions that perform specific operations directly on lists. Every Python programmer uses these methods regularly while developing applications. Let us learn them one by one with practical examples. The append method. First see append. The append method adds a single element to the end of the list. Let's see the program. So is equal to apple, banana, fruits dot append mango. Let's run this. See, see. Before using append, the only 1 minute. Or welcome. Apple banana. Before using append, the list contains elements. After calling append mango, the new element is added at the end. Notice that the existing elements are not affected. Now, extend. The extend method adds all elements from another list. Let's see one program. List 1 equal to 10, 20, 30. List 2 equal to 40, 50. List 1 dot extend of list 2. Now, right, print list 1. Just run this. It shows 10, 20, 30, 40, 50. Unlike append, extend adds every element individually from another list. It combines the contents instead of adding the second list as one item. Now, let's see difference between append and extend. Let us write the program. A equal to 1 comma 2, B equal to 3 comma 4. Let's write A dot append of B. Print A. Now C equal to 1 comma 2. Now C dot extend B. Print C. Just run this. Observe the error. This is one of the most commonly asked interview questions. Append adds the entire list as single element. Extend adds each element separately. Always remember this difference. Now insert. The insert method inserts an element at a specific position. Let us see one program. Numbers equal to 10, 20, 40, 50. Numbers dot insert 2 comma 30. Print, sorry, print numbers. Just run this. Observe the output. Here 30 is inserted at index 2. The existing elements automatically shift to the right. Now remove. The remove method deletes an element by its value. Let us see one program on remove using remove. Fruits equal to apple, banana, orange. Fruits dot remove banana. Print fruits. Just underscore. It means apple, orange. Python searches for the given value and removes its first occurrence. Now pop. The pop method removes an element using its index. If no index is given, it removes the last element. Now let us see one program on pop-up method. Numbers equal to 10, 20, 30, 40. Numbers dot pop. Print numbers. Numbers dot pop on. Print numbers. Now just run this. Observe the output. First, the last element is removed. Then the element at index 1 is removed. Now let's see clear method. The clear method removes every element from the list. It removes every element in the list. Let's see a program on clear method. Numbers equal to 10, comma 20, comma 30. Numbers dot clear. Print numbers. Now run this. The list still exists, but it becomes empty. Now let's see what is index method. The index method returns the position of an element. Let's do one program on it. Fruits equal to apple, banana, orange. Print fruits dot index of banana. Now run this. It's showing 1. Python searches for the element and returns its index. Now let's see what is count method. The count method tells us how many times an element appears. Let's see one program on it. Numbers equal to 10, comma 20, comma 10, comma 30, comma 10. Now let print numbers dot count of 10. Just run it. It's showing 3. Since 10 appears 3 times, Python returns 3. Now let's see what is short method. The short method arranges the list in ascending order. Let's see one program on it. Numbers equal to 45, comma 12, comma 89, comma 20. Numbers dot short print numbers. Just run it. It brings 12, 20, 45, 89. Unlike shorted, the short method changes the original list. Now let's see what is reverse method. The reverse method reverses the order of elements. Alright, numbers numbers equal to 10, 20, 30, 40. Numbers dot reverse print numbers. Now just run it. The first element becomes the last and the last becomes the first. Now let's see what's copy plus. The copy method creates a separate copy of the list. List 1 equal to 10 comma 20 comma 30. List 2 equal to list 1 dot copy list sorry list 2 dot append of 40 in list 1 in list 2. Just run this. Observe the out. Since we created a copy, modifying list 2 does not affect list 1. Now let's see one real world example. Card equal to vending rice. The milk. Card dot append of X. Card dot append of bread. Card dot append. Sorry. Now I will write remove. Mail. Write print card. Just run it. Rice X bread. Imagine this is an online shopping cart. Customers keep adding products and sometimes remove unwanted items. This is exactly how list methods are useful in real applications. Now let us discuss some common mistakes. Beginners often confuse append and extend. Another common mistake is expecting remove to delete by index. It deletes by value. Similarly, pop removes by index and also returns the removed element. Finally, remember that sort changes the original list while sorted creates a new sorted list. Congratulations, we have successfully completed one of the most important topics in Python. In this lecture, we learned list creation, indexing, slicing, traversal, operators, built-in functions, and important list methods. Lists are used in almost every Python application, from web development and data science to automation and machine learning. Practice every program we discussed today, because hands on coding is the best way to master Python. In the next lecture, we will explore tuples in Python, understand how they differ from lists, and learn where they are used in real world applications. Thank you for watching. See you in the next lecture. Happy coding.